Decimals, fractions, mixed numbers, and percentages are related and are simply different ways of showing the same value. For example, this illustration of a pizza divided into 4 equal parts with one part missing can be expressed as the fraction 3/4, the decimal 0.75, and the percentage 75%. Here's a table illustrating common values in percent, decimal, and fraction format. Numbers can be converted from one format to another to make it easier to analyze or display information. To convert a fraction to a decimal, simply divide the numerator by the denominator. To convert a decimal to a fraction, first write the decimal in fraction format with the number 1 as the denominator. Then multiply both the numerator and the denominator by 10 for every number after the decimal. For instance, if you have the decimal 0.375, you would multiply by 10 3 times, or by 1,000, because there are 3 numbers after the decimal. For the decimal 1.82, you would multiply by 10 twice, or by 100, because there are 2 numbers after the decimal. In this example, the decimal 0.75 has 2 numbers after the decimal point. So we multiply by 100 for both the numerator and the denominator. Finally, we take the resulting fraction and simplify it if required. This fraction simplifies to 3/4. To convert a percent to a decimal, simply divide by 100 and remove the percent sign. For example, to convert 75% to decimal format, first divide by 100, which yields 0.75, and remove the percent sign. To convert from a decimal to a percent, multiply by 100 and add the percent sign. To convert 0.75 to percentage format, first multiply by 100, then add the percent sign. Percentages can be very useful when relating real-world system components to design requirements. For example, the National Electrical Code states that electrical systems conductors must be sized no less than 125% of a continuous load. Using this rule, we know that a circuit breaker or fuse must be at least 125% of the load or bigger to meet code. This allows electricians to determine the size of each individual circuit breaker based on the items connected to that circuit. Take, for example, a standard air conditioner drawing 12 amps. To determine the minimum required circuit breaker size, first convert the percentage to a decimal. In this case, 125% becomes 1.25. This new number is called the multiplier. Next, multiply by the electrical load. In this case, it's 12 amps. Many times, a system will call for a percent increase or decrease of a certain component. Technicians must be capable of determining the right size components for the job. To increase by a percentage, simply convert the percentage to decimal format, add 1 to create the multiplier, and then multiply by the original number. Let's work an example in a manufacturing plant. The motor for the conveyor belt keeps breaking, and the engineer has determined that the motor is undersized and requires an upgrade of 35%. If the motor is rated for 15 kilowatts, what is the minimum rating required for the new motor? First, convert the percentage to decimal, so 35% becomes 0.35. Next, add 1 to the decimal value. 1 plus 0.35 equals 1.35. Finally, multiply this value by the original motor requirement of 15 kilowatts to equal 20.25 kilowatts. Decreasing by a percentage can also be a useful operation to field technicians and in everyday life. To decrease by a percentage, simply convert the percentage to decimal format, subtract the decimal from 1, and then multiply by the original number. In this example, an electrical tester is marked down 35% from its original price of $35. How much will the tester cost? First, convert the percentage to a decimal, so 35% becomes 0.35. Next, subtract the decimal from 1. 1 minus 0.35 equals 0.65. Next, multiply by the original amount of $35 to get $22.75. An operation is a function performed on numbers such as addition, subtraction, multiplication, division, squaring, etc. For simple equations, the order may not matter. However, calculating the operations in the wrong order for complex expressions can cause very different answers. For example, 3 plus 5 times 7 seems relatively simple at first. 3 plus 5 is 8 times 7 equals 56. But what if the operations were in a different order? 5 times 7 is 35, and 3 plus 35 equals 38. We calculated two very different answers for the same problem simply because we didn't follow the same order of operations. The term order of operations defines a technique that standardizes the way in which arithmetic operations are accomplished. The rules for order of operations are as follows. Do operations within parentheses first. Next, resolve any exponents. Then multiply or divide from left to right. Finally, add or subtract from left to right. For problems concerning order of operations, remember that the fraction bar can be used to indicate a division sign. The fraction line should be treated like a parenthesis for both the numerator and the denominator. Let's practice. Here's a rather complex arithmetic expression. The first step in solving this sequence is to accomplish operations within parentheses first. 5 times 3 is equal to 15, so the expression is reduced as follows. Next, resolve the exponent. 2 raised to the second power is equal to 4. Then, accomplish any multiplication or division starting at the left and working to the right. The first operation involving multiplication or division is 7 times 2, which is 14. Continuing to the right, the next operation involving multiplication or division is 4 divided by 2, which is 2. The final step is to accomplish any addition or subtraction starting from left to right. 14 plus 15 is 29, and 29 minus 2 is 27. The final answer to the original expression is 27. Let's work an example. In electrical circuits, the current can be found by using the equation I equals V divided by R, where I is the current, V is the voltage, and R is the resistance. In this simple circuit, the resistance is found by adding all the resistors in series. Since 3 of the resistors are the same value, we can multiply 3 times that value and add this to the remaining resistor values to find the total resistance. To determine the final value for the current, we substitute the values for voltage and resistance and apply the appropriate order of operations. First, accomplish any operations in parentheses first. There are no operations in the numerator, but there are several operations in the denominator. Within the parentheses, resolve any exponents. There are none here. Next, accomplish multiplication and division from left to right. 3 times 5 yields 15. Then, accomplish addition and subtraction from left to right. 15 plus 15 plus 20 equals 50. Finally, simplify the answer. The total current in the circuit is equal to 2.